Yeah, vintage, maybe, did you have a look as well?
Yeah, I had a look. I was just more of commenting on specific like errors that the person in the note who created the notebook was saying. So I just was commenting on those, and then also about like scaling the data and whether we need to do that for the Y, which we do not, and like what features we need to specifically scale.
I was also looking at a model, I think it's called a temporal fusion transformer. It's like within the PyTorch forecasting library, which I thought could be quite useful since it's like a dedicated library for forecasting. But I haven't yet got it to work because basically PyTorch forecasting builds on PyTorch Lightning, and they have they have like their custom data loaders, which are I think they use them like from pandas, but for some reason I wasn't able to get it to work just yet, and so I haven't even pushed the notebook. But I might actually push the notebook to the repo later today, just so other people can take a look at it as well.
I'd start before we get into all the fun stuff. I did want to introduce briefly Giuliano, who's a fresh face here. So he's
Hi there.
He's a new member of Team Window Finance, and probably better you than I to give an introduction. But maybe Giuliano, you want to say a word?
Yeah. So yeah, I started working with Window Finance about 10 days ago. Was it that? Yeah. And I'm pretty excited with the work that they are doing. And then they introduced me to your community, and I was pretty excited by that as well. So I'm happy to be here. Today I'll be basically watching. I did introduce myself in the introductions channel, but you probably won't remember. So my background is basically, I'm a kind of a generalist. I've worked as a software engineer. I've worked as a researcher. I did research in decentralized, large-scale distributed systems, but that was like 7 years ago. I actually left just as blockchain was becoming mainstream in the research community. I remember the last peer-to-peer conference I attended was basically talking about blockchain, but I missed a lot of that. And then I spent some time working as a developer and as a data scientist in a number of places until I landed back here again, where I can kind of get back to what I find interesting, which are decentralized systems, and reconciling that with data science, which I like as well. So I think it's all very, very good. So thank you.
Fantastic, welcome. Yeah, this is like the world of generalists, you know. This is the place where you need generalists the most, because there's just so much to keep up with on all the different sides. So great, yeah, it's great to have you here. What sort of data science did you work on? Was it finance related?
No, I did some, well, it was I did work in a business intelligence product, and I was doing data science work there, but it was not specifically related to finance, although we had some interfaces with banks and insurance companies, which were mostly our customers, most of our customers. But I did work with NLP, and then I moved on to a music intelligence company where I was working with forecasting artist performance, trying to understand cause and effect, so trying to automate marketing, figuring out which marketing actions were working and which weren't, you know, trying to pick up, understand what would make an artist grow or not, and stuff like that. Yes, I could probably give more details at some point if you'd like.
Very interesting.
Yeah, thank you.
Before we start the hacking as well, I think it's worth to note that in case everyone have not seen, we have submitted our grant proposal on the Algovera forum. So we're waiting for the result. I think the voting starts on Monday. So yeah, if you guys are having as much fun as I am here, so we should probably vote starting on the Monday.
There's so many people in these hacking sessions. I think it should get a few votes. So I think we've a good chance. And yeah, like it's the DeFi hacking sessions have been so successful as well. I think it would be great to get this, even if it's a small amount of funding, just to, you know, start to reward people working on it. And then like maybe even was chatting to Greg, maybe like even put in a grant, an ocean grant or something like that to progress it even further. I think that would be really cool. Yeah, like I think there's a huge amount of value here. And so, which should mean that we can, you know, raise funds to reward people working on it. So yeah, I'm excited to see where it goes. And hopefully a successful Algovera grant is just the start of it.
Yeah, and I hope, you know, through Component, when we get to the point where like we can start doing grants and stuff, you know, we can like do the same thing, because we're all kind of working towards a similar goal. Because there's so many things, you know, that you can do with ML. Like it's just the tip of the iceberg. Like just considering, I think I mentioned this a while back, but like just considering like Uniswap V3 LPing, like there's probably a dozen companies that are focused specifically on that, like using optimization and ML to predict what prices they should like LP at. So like there's just so many applications. So I think we'll do a lot of cool stuff here, especially as it grows like more and more.
Yeah, and we're right at the start as well, right? So like people are starting, I think, to do really basic ML models. So we're so early to this, and so there's so much opportunity as well. And so yeah, like in 10 years, we could be saying, you know, we were some of the first to play around with machine learning and stuff. So yeah, it's really exciting time.
Do you guys have any suggestions on how we should do the hacking today? Maybe we could explore the PyTorch libraries that Jacob was talking about, or maybe we could expand on the linear regression models. But I do feel like the linear regression models were kind of running out of input variables, because we saw that it's very, very highly correlated with the deposit rates, but that doesn't, I don't think that help us too much, because, you know, if you're thinking about a point of time T0, if you already have the deposit rate, we could calculate the borrowing rate, but in the application scenarios, we would not have either of them. So yeah, I was trying to explore any maybe more another input variable that could give us a better output. What do you guys think?
Yeah, that sounds good. And another thing we can look at is the notebooks that Archie was working on. So he was working on splitting up the training and test data with the first part of the data as the training and the last part as the testing, which should mean that it's a harder problem for the machine learning algorithm. As I was saying before, if you have two time steps either side of a central time step and you're trying to predict the one in the middle, that's an easier problem than if you have two time steps at the start and you're trying to predict the next one. And so what Archie did was he separated them according to like the first and last, and still got really good accuracy with it. I think it dropped a little bit, right, compared to the first way of studying.
Yeah, it's getting 90s instead of like 99.
Yeah, but it's still ridiculously good. And considering, I think he chose like the first 80% as the training and the last 20% of the test. But that last 20% is still quite a lot of time steps. So it's predicting quite far into the future. So if you imagine if you're on the 80th percent and you're predicting the one that's, you know, the very last time step, I'm not sure what exact amount of time that is into the future. Christian, do you remember how long the whole...
We're splitting it. Is that data set the one, the 30-minute interval one?
I think...
I think so.
Yeah.
So 20%, well, I think it's probably about a year. So the entire data set is probably about a year, right?
Yeah. So if you're predicting 20% of the year into the future for the borrowing rates, that seems too good to be true. So I think how I would approach this from as a data scientist would be like the models are really interesting, but until you're sure that you're separating the data properly and not like leaking information that it wouldn't have, that would be where I would start. And then once you're sure about that, and you're not suspicious of the crazy high accuracies that you're getting, that's when I'd start to play around with the different models. So I don't know, should we maybe try and have a look at the notebook that Archie put up?
Yeah, I think that works. I was a little bit curious about the models that it was used on the notebook, because personally I think I have never came across to them. I think it was TabNet and another one, and they're both linear models. Like, do you guys know what's the big difference between them and the good old linear regression we were using before?
I had never heard of it either.
I think the second one was the Saint model, which is like just a transformer that has like an attention layer that takes both like the rows and columns at the same time, and like I think it goes like a couple of rows in the past, which is what's supposedly making it like pretty good for tabular data. But I think that Archie said that he would work on that implementation later. I don't think that's in the current version.
I just joined to share my screen so we can have a look. Yeah, they were linear models, you were saying. I thought they were some sort of neural network or something like that, but I didn't look.
I thought I read somewhere they were linear. Not sure if Ashley itself said that, if it's so. With my research, I found it, but I can double check.
And yeah, the transformer sounds really interesting as well, Jakob, that you were mentioning. They're the ones that I really want to work towards, because transformers it's this type of model that has just taken over all other parts of machine learning. Like everything uses transformers. It started off with language, and then it moved into like computer vision. And for some reason, it hasn't happened in time series forecasting yet. So, but like it will be a good bet to make that these are going to take over time series forecasting at some point. So it'd be great to like have a look at those in future.
The last time that I was, oh, sorry, go ahead.
I was just gonna say, yeah, transformers, because they can look, you can make it so that they look, both directions, or you could even go farther back in time than like a typical LSTM. So, I mean, language, as long as it's sequential, language is sequential, this data is sequential, all those models will fit.
Yeah, and they can look further into the future. So another type of model that Archie trained was the LSTM, which is a recurrent neural network. And so the idea of that, so at the moment, like if you're using a linear model, it has no idea what order the time steps are in. So yeah, it just doesn't know what a sequence looks like. It's just a set of time steps that are passed in. And so that means that, we're not providing it all of the information that we could. And so one way to go towards fixing that would be using a recurrent neural network, which knows the order. It's like a sequence model. So it's made to operate on sequences, whereas the linear model is made to operate on kind of discrete things with no relation between them. And so, but the issue with the recurrent model is that it really struggles with remembering many time steps ago. And so that was where the idea of this LSTM came in. It's like long short-term memory. So it's like a recurrent model that gives you extra memory for more time steps. And that's the one that Archie trained. But then where transformers can add even more value is they don't forget as much. And there's also ways to make them treat the input data as a sequence as well. And so that's where transformers can help in future.
Yeah, so LSTMs, they're taking, so they're randomly generated weights in the beginning of its process. And then as it reads through the data, it propagates these weights forward. So then as you read more data, you know, each success is like built into these weights. So it has like kind of like a memory with these weights, and then the weights reach the end and the weights have been updated from all of the data. So that's like the mechanism that the LSTM works on. I'm actually not sure exactly how transformers work with the attention. It's a very different concept though. They approach the same problem very differently.
Okay, so that's
Yeah, and one thing I was going to mention, Richard, kind of interrupting this because it's a different topic, but is just with regards to like the type, I guess the data engineering or like the data sourcing, as you were saying, like is obviously pretty important. So I was thinking like I guess we should set up a process for like requesting, you know, new data and like new input variables. I don't know if we can just do that through the GitHub, like through issues or what, but I was thinking like, because I'm happy to do a lot of you know, some work there, and like some people from my team can help out too. But if we can just kind of clean that up in a sense of like, you know, we know exactly what we want, and then like by block, you know, these type of inputs for this protocol, for example, and then we can just go ahead and do it, like merge it in.
Yeah, that would be great. I'm just trying to think what a good process would be there. So like, I think in future, I actually spoke to another guy from Ocean. They're from Ocean Missions is the name of the project. And they want to fork the Ocean marketplace and have a marketplace just for DeFi data, which would be really cool. Which is just, it's kind of related. I don't know if you remember, I was talking about Quantopian, which was this framework for like building predictive models purely on like finance, like stocks and finance data. And so that made it really easy to like just load finance data into a notebook and really quickly play around with different models, and all the data would be in the same format and all that sort of stuff. And so like how that might look in future is like the Ocean marketplace in the back end, which is a fork of Ocean marketplace and just for finance data. And the people who like who are part of that marketplace, you know, make it in like a standard format that's reusable across, like everything relates to each other in terms of timestamps and stuff like that. And so I guess that's like the dream. So, and then how do we start working towards that in terms of adding data sets step by step?
Yeah, well, what was the company called? Sorry.
They're just like, I don't know if they're a company, but like Ocean Missions is the name. So they're on Twitter. They have a Discord as well. And the idea actually, they like, so they're focusing only on DeFi data, and they put up these like missions. So they're kind of like bounties. So if someone wants some sort of data from the blockchain, they put up a mission, and then a data scientist will work on it. And so I think the data scientists in their community are more like kind of analytics than machine learning, I would say. And like just a few people who are good at like querying the blockchain and doing analytics and all these sorts of things. Let me see. Yeah, they have a website.
No, that's not them.
It's not.
It's a site for oceans, like missions on the ocean. But no, I'll check them out. I'll check them out on Twitter.
Yeah. Anything I type with ocean just always gives me the wrong search result. Like the place to propose the grants is called Ocean Port. And so I like Google Ocean Port. And then of course that's not going to lead you to just pictures of like a port in the ocean. Yeah. But yeah, they do have a website. So if you go to their, let me see if I can find it. But yeah, it would be really interesting.
It's just the .com, not the .org.
Yeah, I have it here. But yeah, it would be a really good place for you to look around and just see what sort of missions people are working on in terms of DeFi data and stuff. I'd love to build collaborations with us and them as well. I think that would be really useful. Oh yeah, it's just oceanmissions.com. Link it here. Actually, I'm on 2 different PCs. I can... So my screen's not sharing for you?
We're seeing the Twitter page
Oh
of
yeah.
the Ocean Missions.
Okay, you got it. You got it. For some reason I can't share. You can probably see it there anyway, right? Oceanmissions.com.
Yeah, got it.
You got it. Yeah, just have a look around and have a look at the missions and what sort of stuff they've been working on, and see what you think. But yeah, in terms of process for data, does anyone have ideas? I guess we're working out of oh, sorry, go ahead.
I'm gonna say, Christian, are you talking about like when we do this type of analysis, reach out and say, this is the type of data that we think we would need?
Yeah, exactly. Like last call, we probably mentioned, oh, it'd be good to have this block by block, but like having somewhere we can officially like just kind of
right.
that in.
Yeah, write that. Yeah.
Like, so I have it as a task and, it can go and like complete it. Like if we want, Aave, I think, I forget whichever one we don't have by block, like sourcing that by block, maybe adding in these 10 metrics, getting the same thing for Oasis Borrow, like MakerDAO, adding in a couple other lines, like whatever it is, just having, and I don't know if GitHub issues is the right way to go about it, like in that repo or through Notion or what the best, keeping it simple is fine.
Is there a way to automate this process, like for Dune, like with Dune analytics? Like kind of like, is there a way to have like like a Python interface for Dune analytics? I'm not exactly like what's like the workflow for getting the data from Dune?
It's like
yeah, it's SQL. Yeah, so they have basically like a web interface that allows you to write SQL in there, and then you basically just had to download it from there. I mean, there's other ways to do it. Like you could use a Python script to like pull data from the graph like through an API. That might be easier. I can share actually like a good little script that I have for pulling data from the graph, like just through subgraph APIs. It's just not as reliable as Dune because it's easier and probably better infrastructure, but for the graph, like the reliability of the subgraph you're pulling data from isn't necessarily very good because it requires like indexers, curators, and all these things. So like the subgraph that we want just might not have any signal. So
Dune doesn't have an API.
No, not yet. But they just raised didn't they just raise a lot of money? So maybe they'll build one. Yeah, they don't right now.
I could also help getting data from the graph, but I'm not sure if it's needed for now. I think if you just get the CSVs from Dune, it's a better place to start. And then after time, we can just download a new CSV and compare to the predictions we're having. Like I'm not sure if you need to automate this process already. I think what's important is just figure it out which data we need. Like what else do we need to make those models? Even like outside of the protocol. I believe like token prices is something that's good to look at because like we could see if, for example, if the Aave token price is actually affecting somehow the rates or even the overall market, stuff like that.
Yeah, and I think one thing we could all collaborate on, like either today or in another session, is choosing like a set of 20 to 30 variables that we'd like for this type of problem, like as input variables.
Mm-hmm.
And then, so we basically have like a standard taxonomy for lending protocols that, we know that's our go-to taxonomy, and then we can just essentially grab those specific variables from any other protocol.
I actually think this would be a good practice to do today, because I feel like we've done a lot on the initial data sets we had, and there's a chance that there's not too much more in there than we already looked at it. So it could be a good idea to try to expand the horizon. What do you guys think?
Sounds good.
Yeah, I agree. I think talking about data is a good step.
I think I'll open a shared document and then we can start from there.
I think we can put into like 3 buckets. We could say like top priority data, and then like medium data, and like low priority data would be good.
The other thing that we could do after that is just figuring out the deterministic nature of the borrowing rate, like figuring out, is that just at the current time step? Remember what I was saying? Like, is it deterministic just within one single time step, or does it depend on historical data and that sort of thing? And like, since they're equations, maybe we could dig into the equations and see, what happens as a certain parameter increases or something like that. Just kind of look at it analytically using even graphs to see what happens as you increase one parameter. Just the relationship between the different parameters in the equation, I think, would be useful, because I definitely don't understand those fully. Yes.
Okay, Christian,
Yeah.
maybe we
Go on, sorry.
Because Christian's shared that notebook. Forget what type of notebook it is, but maybe we should just click on that and kind of walk through, because it shows up, it basically simulates the effect of them, I'm pretty sure, or at least you can see it over time. So I think that's a good notebook to go through as well.
Oh yeah, the compound one.
Yeah.
Okay.
And also because I think it sets our response variable more clearly for everyone. Because, for example, we're trying to predict the borrowing rate, but if you look at the deterministic models and the borrowing rate is actually determined by, I don't know, the borrowing volume, then maybe we should just take a step back and look at another response variable. It might not change too much, probably won't change too much, but I think it gives a better idea of what the problem is. Christian, do you know, like, if compound is clear about which deterministic models out of those 17 they're actually using?
Yeah, I'm pretty sure that you can grab that info from directly from a smart contract. We can check the subgraph maybe and see like if that information is in there. I'm not sure what the best way to check that would be. Like, I'm pretty sure there's a variable like in their smart contracts that says like what interest rate model it's using. But we'd have to check. I guess we can. I can just share my screen and like we can try and figure it out. Unless someone else wants to do it.
I have the link up, but if you could just speak to it, either one works though.
Sure. Yeah, go ahead. If you want to go through the compound interest rate one. Right. So one key thing here is, so there's 16 interest rates, and I think one really important variable, which something that we should note down, is when and why, or why and when do these interest rate models change? Like, why would a market change from one interest rate model to another? I actually don't know, but my guess is that it's actually governance based, but I might be wrong. And this type of thing could change, protocol to protocol. And I'm pretty sure this is up to date in terms of like the data being relatively real time, but or at least like the interest rate models being right for each market. But yeah, essentially here what you get is the network that it's on, and then the compound token, and that's essentially letting you know all the different types of things that you can deposit, or I guess in this case, borrow against. Do you know, actually not sure if the interest rate models for this are for depositing, for borrowing. I imagine it's for borrowing. I forget what their taxonomy is, because I think they call the interest rate, I think that's the borrowing rate, and then the deposit rate would be like the deposit APY. So I think this is for borrowing.
That's what I understood as well.
Okay, cool. So yeah, I guess just we can walk through this. I guess these are just assumptions that you make that will change the below graph. So seconds per block, total supply to the market. And this is important because this kind of tells us as well what variables we should be including. And then reserves held by the market. So total supply to the market, I guess, is just the amount of collateral that's been deposited in that market for DAI. So I guess the amount of collateral that's been deposited for the C DAI market, specifically on Compound. And then the reserves held by the market. I don't remember what their definition of reserve is. Does anyone here know? I can probably quickly check in the documentation. Their documentation's annoying because you can't, there's no search bar.
Could it be like one is the amount of DAI supplied and the other one's amount of supplied in for all of the tokens?
That might be it. Is it does it say total reserves? Sorry, at the top, or is it just?
I think it says market reserves and then total supplied
reserves
actually.
Total.
Yeah.
Okay. So the reserves are essentially cash that can be withdrawn or transferred through the protocol's governance. So a small portion of borrower interest accrues into the protocol, which is determined by the reserve factor.
Okay.
Yeah. Yeah, so the reserve factor defines a portion of borrower interest that is converted into reserves. Okay.
And
cool.
And that's held there in case of a lot of liquidations to cover the difference, maybe.
I think so. Yes.
Because I know Maker has like some type of mechanism like that as well.
Yeah, Maker has when there are liquidations, I think what happens is essentially like the amount that is liquidated from each account then goes up for like auction, and then people are basically able to purchase that those liquidated DAI, for example, or ETH, and like at a cheaper price. So they're able to get like cheaper collateral essentially, or they're able to buy it at a discount. But with Compound, let's see, liquidate. Right. Yeah, so I think that's about right. for liquidation, I believe. But yeah, I suppose we should look at like what the actual chart is below. So the borrow rate versus the utilization rate, right? Because I think this is quite an important, like I think it's deterministic essentially, right? And it's kind of showing that as you know, one changes, it'll show like the effect on the other one, right? And I guess at the, does it show like the calculation for it anywhere here, or just like the function that they call?
Is utilization the amount of people borrowing at that rate?
It's the amount of the, like the percentage of the supplied amount that has been borrowed.
Gotcha.
It is interesting though, because there is a breaking point there where the borrow rate just skyrockets. So that's
kind of
good
awkward.
to know. I'm also thinking, Christian, that if those deterministic models are changing and the governance might be the ones that deciding that, if you could collect some governance data, it could also be helpful to predict those. Have you ever touched on governance data? Do you know where to get them and stuff
So
like that?
it depends if the governance data is on chain or not. So like if, for example, they publish anything on chain, like when something, well, I mean, for sure what would be published on chain is that like the interest rate would change. So they're like, for example, you know, say 1 block ago before the change, interest rate model is equal to 1. And then after the change, you know, interest rate model is equal to 6 or something like that. So there would definitely be a trace that way. But with regards to like before that, like the true alpha, I'm not sure how Compound operates specifically, but most protocols have like a, for example, with Maker, like they have MIP, or Compound might have like CIP, which are basically compound improvement proposals. So generally how these things would start is someone like either from the Compound team, like the foundation, the team, or someone in the community would put forward an improvement proposal. And that would essentially, and in this case, if we're correct in saying the governance changes this, someone would say, okay, for the CDI market, we should change the interest rate model from 1 to 6. And that would essentially go through voting. A snapshot would be like probably on something like Snapshot, and then it would go through, and then that would actually be changed like on the blockchain after all that happens.
How different are the different models? Are they very different? And how many? Oh, these are all the different models?
So these are all the different markets. I don't know if they have their own models or not. Like if they're, it says Compound currently has 16 interest rate models in use. Maybe if you click on the interest rate model itself, would it show all of them maybe or no?
And it shows the contract address that they all use.
Yeah, so like there's jump rate model V2, there's just jump
Yeah.
rate model, die
I
interest
think
rate model
if you
V3.
take the address and paste on a field below, like the enter another model, then I think we can see the difference. Like below the reserves held by the market.
Oh yeah, there's a text box.
Are you talking about this drop down? Or are you saying here?
Yeah.
No, yeah, here, yeah, exactly. Not sure how you would reference the models, but
Which one would we want to look at?
I don't know.
Jump rate? I guess I put in the contract or the model address.
Probably the name would be my guess. Maybe the address, yeah.
I just don't know what variable that goes with, but let's see.
Maybe take
Try to take the, yeah.
Quotations. Oh, nice, yeah.
Yeah, nice.
So
Looks very similar to the other one though.
I went way out of my league on that one. I was gonna be like, oh, maybe I can just make 2 plots, but I don't know this very well.
So I just confirmed that governance basically approves change to different markets. So you guys know Dharma. They just got acquired by OpenSea actually, but I see like here historically they made, was back in 2020, but they made a proposal to change the CDI interest rate model, and it passed, and so that's what changed the interest rate model for that market.
Would you mind share that you're looking at? Because I think it's interesting to see like why they're changing and what's the pros and cons of each one.
Yeah, it's just an old article. I shared it in the chat here. And this is where you would see like all compound governance proposals in the link that I just sent. So like they just, on January 18th, something passed, which was risk parameter updates for ETH. Which is interesting. So yeah, they wanted, so, okay, cool. So for this, basically the loan to value ratio, they wanted to change it from, or the ETH collateral factor, which I think is basically the same thing as LTV, is they changed it from 80% to 82.5%. Which is like I mean, a relatively significant change. If it changes kind of like the amount to which you get liquidated. You can basically like safely borrow more.
So it seems like all of the parameters are the same. Well, the models have the same parameters. It's just that the parameters are different for some of the models, like 80% versus 45% or whatever.
Yeah, they change in those drop downs or these sliders. Excuse me. They change these variables. So the amount of supply, the amount of reserves, and the supplied and reserves calculates the borrowing rate, which is here. So it's supply plus reserves divided by 100. Do you know why they divide by 100?
No idea.
maybe just to get it into like 10s and 20s. So I guess.
Yeah, to normalize it.
So this is like the ratio. So utilization is a ratio, right? So the amount of reserve compared to, well, I guess it's amount of supply compared to the reserve. So if your utilization is higher, your borrow rate will be higher.
Yeah, which makes sense.
What does that mean exactly? Can you explain that?
Means as the reserves, well, as the collateral gets lower, it becomes more expensive to borrow because there's more risk, I suppose.
So because reserves taken from the borrowing, right? Like every time someone borrows, compound takes a little bit of that interest, puts it away. And Christian, you said it was to cover liquidations. Is that right?
So here it says that, so the utilization rate is an indicator of the availability of capital in the pool. And the interest rate model is used to manage liquidity risk. So yeah, that's what it says here in the docs.
Okay.
So yeah. So what exactly is the utilization ratio again? Sorry, like does it show the calculation here?
Yeah.
I think it's the amount of this supply that have been borrowed. So if there is $1,000 supply and $800 borrowed, then it would be 80% utilization rate.
Right.
Which would mean
Affects the borrowing rate because it's pretty much just tracking the demand and supply. So
Right. It's the amount of capital available in that pool, right?
exactly. Not available, but used is actually the other way around.
right. So the higher amount that's been borrowed, the less the pool has.
Makes
Is that right?
sense. Yeah.
So then borrowing would be higher. Okay.
It is funny because as you see, like this market is using this 5 plus 12 multiplied by the utilization rate. I wonder how they came up with these coefficients, for the slope and the intercept. Yeah.
Right. So yeah, like what you're saying, just to reiterate, is it's essentially the utilization rate is essentially the amount, the percentage of money borrowed out of the total money that's been supplied.
Yes.
So a high ratio means like a lot of borrowing is taking place, like 80% of the available, like of the supply is being borrowed. So interest rates will go up to get more people to inject cash into it, essentially. And then a low ratio would mean that the demand for borrowing is low. Like there's not that many people borrow. Like say there's a mill, but there's only like 100K being borrowed. So interest rates will then go down to encourage more people to borrow from the system because it's an attractive interest rate.
Yeah.
So just basically it's like that supply and demand.
Exactly.
I just noticed.
So I think in order to anticipate the borrowing rates, would have to try to anticipate the money going into these protocols, because it would mean a higher supply or a lower supply. So we would have to track money in and out of these protocols, at least in my mind.
I noticed the utilization rate goes above 1 as well. I think it goes up to 1.1. Can that ever happen? Or is that just a plotting thing?
Which token was that for?
Just on the graph, you can see on the x-axis, it goes up to 1.
Oh,
I don't think that's
this
possible
is borrow.
because
I think it's just the plot line and
borrow rate versus utilization. Yeah, so the x-axis would be borrow rate. Isn't it usually x versus y or no?
Oh yeah.
That's what I thought.
I just assumed utilization was between 0 and 1, but
yeah, that's weird. Unless that whole number means the percentage.
I just saw that. Yeah, let's double check that. What's on the y? See if I can read it well. X. X is the borrow rate. That's what I got from this. And Y is R.
Was the variable borrows ES? Borrows is not the utilization?
No, actually X is the utilization rate, because I think it's borrow is divided by supply, and then the Y-axis is this error variable, which is probably the rate itself, the borrowing rate. So I think it's just a plotting thing that went over 1.
Well, or it's a formula, so maybe it's defined for values above 1, but it doesn't necessarily make sense, right?
Yeah, that's what I'm thinking.
Yeah, it could just be like the limit, the axis isn't set.
Right.
So what other so we would want to know, because people would take or put in more supply if the rate is high. And I guess you would think that more people would supply. I guess we would want to see the pricing, you're saying? Like what's the relationship if an asset goes up or down in price? What's the effect on borrowing it or supplying it? Because if you took it, if the price went down and you borrowed it, you would owe less money. If you supplied it, you would earn less interest. So you kind of like, so I think they should affect one another. That was actually a strategy I was trying as well. I just didn't have an automated way of doing it, but yeah, that's a good.
Yeah, and it also measures how people are looking at the token, because if the token is trending up, then it's possible that people are gonna borrow other tokens to buy this token itself, and if it's going down, they're probably gonna take off their supply and maybe swap or do something with them. So I imagine that's got to be something there, but it's hard to track because they could be just swapping that token to do whatever. So yeah.
But it also like a market cap, because that at least takes into account also the amount of supply of that token. So I feel like if you know, like one Ethereum is worth more than a Cardano or an ADA. So I think market cap would be able to take both of those into account. Might be a good additional data point.
So I guess like so what changes the borrowing rate is like how much the supply and reserves has changed since the last time step. Would I be right in saying that? When do you get that information? Does the information all come at the same time? Like the new supply, the new reserves, and the new borrow rate? Or is there some way to know about how the supply and reserves have changed before the new borrowing rate is announced?
So I think it happens at the same time, right? Because like all of those transactions, like let's say that all the supply and the reserve change in one block. So all of that gets submitted to a block. That block gets mined. Then that would update everything as of the next block.
Mm-hmm. Mm-hmm. Okay.
Yeah, I think that as well.
Yeah, I would think that all of it would be submitted in the same block.
Mm-hmm. So if you only have the information at t-1, it's not deterministic to calculate at t0.
I'm sorry.
No.
If you had a t-1, you wouldn't be able to calculate it at t0. Is that what you say?
You wouldn't be able to. Yeah.
Yeah.
Okay.
Yeah. So in order to calculate at t0, we would have to have at least one of those variables.
Yeah, so it's all deterministically linked at t0, but in the next timestamp, you don't know any of it. You could predict what might happen, like more supply might come in, which then affects the utilization rate and the borrowing rate. So I guess predicting any of those things well would be good, because then you can link that to other things.
Yeah, perfect.
Yeah, but they're so connected together that it seems like the problem to predict the supply is very similar to the one predicting the utilization rate and the reserves and everything. So
yeah, I mean, at the end of the day, you're basically predicting like how people are going to put in or take out money, right, in these markets, because that's what affects everything.
Yeah.
So do we have supply? I forget if we have supply and compounds data.
Yeah, I was going to ask, do we have these in our data set, the reserves and supply?
I think the total supply or the supply rate?
Yeah, deposit rate.
I guess we have the volume.
Yeah.
So in this calculation, so we can create our own utilization rate, right? We just divide.
Yeah, exactly.
So this number, no, it's borrow.
But yeah, it is.
Oh,
It is the
it?
borrow volume divided by the supply volume. Pretty sure.
Utilization is the borrows divided by the cash plus the borrows minus the reserves.
Yeah, we just don't have that cash. We don't have the reserves number.
I should be able to get that.
Yeah, so I would say that because it would be volume plus reserves, then you divide by the supply or whatever this calculation is. Supply plus reserves. So This is just looking at it the opposite way, because it's.
I know we're
uh,
at time here, but I can show you quickly like the data that we can grab like right now if we wanted to.
Do you think that there's a chance we could use those parameters from other protocols? Let's say we have 5 landing protocols. We could use the parameters of 4 of them to predict the 5th. Because like if the borrowing rates are expensive somewhere, people are going to move around their money to other protocol.
I think you could, what would it be? Withdrawal. You could probably get withdrawals. So you could figure out what would that, like retention might be like that measurement, or turnover or whatever.
Yeah, because I feel like the protocol you sent or you mentioned on your notebook does exactly that, right? If a rate is too expensive on one lending protocol, we would just withdraw and deposit elsewhere.
Yeah, that's basically like rebalance. That's like what DeFi theory does, right?
Yeah.
Except they're not predicting anything; they're just reacting.
Then
yeah,
also,
like for. Oh, sorry. Go ahead.
I was going to say, in addition, or like another strategy too, you could just swap different collateral if you got a higher supply rate. So really, whichever method, if the final product was trying to determine whether you should leave the platform and get this other interest rate with the same asset, or if you should stay in the same platform. I guess with like gas fees going down, it might not be as big of a deal. But
it depends who your target. If your target market's institutions, then gas fees are relatively negligible even on mainnet. But this is exactly what I'm talking to a couple funds about actually. Just kind of collaborating with them, but like pretty much what they work on, like these crypto hedge funds, what they work on 24/7 is staying on top of where they should rebalance and like when they should swap collateral or swap to different protocols to like maintain, whatever APY they've promised to their LPs. But I was just showing you here, like this is just pulling directly from like the markets, the compounds V2 subgraph. And so like you've got borrow index, rate, cash, collateral factor, like everything we need, reserve factor, reserves, supply rates,
I think the only thing that they don't give out is the rewards rate on the compound subgraph.
Yeah, so we have to figure that out, the distribution APY, which is important because it can be the tipping point of whether you want to swap to another type of collateral or like swap to another protocol.
What does cash mean in this context?
I'm not sure actually. It says refers to the amount of A left in the system, where A is just the market.
All of compound.
Amount of A left in the system. Yeah, I guess. So like say the money market is DAI, so it's the amount of DAI left in the system.
Yeah, but I do think like if you have a snapshot at T0 of all of these parameters, including utilization rate for each lending pool and the borrowing rate for each lending pool, you could try to track where the money is going because people are going to reallocate or rebalance. I think that's the best case I can think of making a prediction.
Yeah, I think all of this
across
is
multiple
important.
protocols. Yeah.
Yeah, if we get this exact same information pretty much for multiple protocols and multiple stablecoins, and then add in the rewards for each, then I think that's all the data we'll need initially.
Yeah, and honestly, even though we might be predicting just for stablecoins, I think we should have the landing pools for other tokens as well, because people could be moving their money out of in and out of those, and it could be affecting.
Yeah, totally. And like that's just a different category in terms of risk because like, you have to hold a volatile asset, but so I think it makes sense to start with stablecoins, but for people who are open to more risk, why not any money market? Or I don't know if that's the right term, any market.
It seemed, at least from my experience, that supply rates on non-stable coins are really low. And the borrowing rate is also pretty low just because of, like Christian's point, they're so volatile. that they don't want to reward you, or I guess de-incentivize you to borrow, because you're at the risk of that asset.
Yeah, you also have to take into account if that lending pool, like if that token, you can use it or not as a collateral, because tokens that cannot be used as collateral usually have higher rates, especially because you can't do anything with that deposit, so they will pay you more for depositing there. So that's a good thing to track as well. So I'm setting up the document with all of the data. I'll send on the Discord and help me remember everything we spoke today and put it in there. So yeah.
Great. Yeah.
Do you mind putting a hashtag below it that says like task tracker, so that we can just search for it easily?
Okay.
Yeah, that was really useful to get through the equation for that. I think I have a better understanding myself, and at least we know it's not deterministic. So it still doesn't explain why we're getting such high accuracy. So what I might do this week is like dive in on the modeling side and just make sure that we're not leaking any data between the training and test set or something like that. Because yeah, if we can predict 20% of a year into the future for something that isn't deterministic, that's really suspiciously good. So yeah, maybe I'll try to set up that problem so we know that it's correct, and then we can like train different models using all of the different features that we were talking about today. So I think that sounds good.
I was going to dive into it though. So
yeah, I think just a good practice after having the data is just running a simple correlation analysis and seeing which variables are affecting more the response one. So yeah, just the same thing we did before, but now with the new variables.
Yeah, I agree. And predicting that far into the future is what's interesting, because if you predict, 10 minutes from now, it might just be that the probability that things change a lot in the next 10 minutes is low. So you're predicting something that's close to what what it is at T0, but that far is interesting.
Yeah, exactly. And like, I want to plot the predictions. Like if it's predicting like this really like noisy line to high accuracy, if we can overlay them and see what the actual value is versus what the prediction is, and it's predicting all this noise, like that's really suspicious. And so I think like I'd be confident there's a bug somewhere that we need to find. And yeah, once we find that, we can be more confident in that we're training it properly. Okay, cool. All right. Yeah, that was really interesting from my side. As a non-DeFi expert, I feel like I'm starting to get a better grasp on the world of DeFi, which is great. And yeah, just seeing the equations and how it's all done is really, really cool. So
yeah, me as well. I've been interacting with these protocols, and now that I'm seeing that they have so many different models to calculate those rates that I'm seeing, so that's good.
Sweet. All right. Thanks, everyone.
Thanks, everyone.
Thanks, guys.
Thanks, guys.
Thanks, guys.
Chat to you soon.